Hi everyone, I'm very excited to present you Minerva, our cybersecurity AI agentic tool. And I've been in cybersecurity more than 11 years. And these 11 years I've seen a lot of challenges, faced a lot of pain. What I was thinking, how can we automate this kind of manual work? How many of you guys are in cybersecurity or has previous background in cybersecurity? Couple, yeah, thank you. So even if you have a background in IT operations, we have so many tools that are bombarding us with alerts, with different kind of notifications that at some point either our mailbox is full for the day or we have other tools that are combining those and they are also full. Then we don't know what to do with those. And then in the next day we take a look at those alerts and figure out, we don't know what happened. So what Minerva does is bringing these tools together. And just a second, I'm going to log in. We are combining different alerts from different softwares, which alerts you, meaning the software tell you it might be an attack or might not be. Human, look at yourself and go through the logs. So almost everyone has an IT operations background here, and you know how painful it is to go through hundreds and thousands of log lines. And imagine you do it in your daily work job. At the end of the day, you are done. So what we do is we leverage local LLMs. We used to work on Llama 70B, and now we use Qwen 3 235 and have done middleware where we have done a lot of prompt engineering, feeding a lot of information, how alert analysis, cyber attack analysis is being done, and feed that into the LLM. These are the alerts from different tools. What we do, you see here, if you open the dashboard, you promptly see, is it a benign alert, or it might be potentially suspicious or potentially malicious. If you were a human, or you are a human, then you would go and actually prioritize those that are potentially suspicious or malicious. We generate also a report that you can see. We tell you actually the story, what happened, when did it happen, and what are the steps that you have to do. What you can also do is you can actually chat with your alerts, meaning we leverage lots of information. We bring hundreds and thousands of log lines, ingest it to LLM, and you can actually ask the most important questions from that incident, or you chat with your log lines and you get back those information. Additionally, we get also intelligence from the web, and in cybersecurity and mostly in IT sector, the cool part is that we share a lot. Like in different websites, there are lots of advisories from NSA, from CISA, FBI, from BSI Germany, and different other threat intelligence sources. There are different agents. We call them tools. We have tools because behind tools there are different agents that communicate with each other. We have web search that takes the user's prompt and goes to the web and brings back the relevant information for the alerts and the questions. We have built up a database internally where it goes and makes database of your software that you have spread out in your infrastructure, and also the assets and different alerts that come in. You can also upload your documents, internal documents that you have. You might not want to publicly upload it to OpenAI or different other cloud providers, if you have like an incident response process with phone numbers and emails, and you might have like other documents that you have as defined as confidential within your company, then you can ask those actually, and the LLM can bring in, when it comes up with the answers, give you recommendations in the incident response process. And there are trusted sources of cybersecurity where we go and periodically scrape those data and give the user those information. I've prepared some questions here. It is, for me personally, I still do cybersecurity and analysis. It's extremely helpful every day when I get these kind of reports saying, when I say, give me a summary of what happened in the past 24 hours. Otherwise, I would have to go to news, through the documents, through a lot of sources to be able to have this summary. So right in the beginning of the day, I'll get this summary, and then I can actually concentrate on the most relevant and the most critical attacks. So we give also the sources where these information come from. One of the attacks currently, which is quite popular and have been in the past weeks and days, is scattered spider. I want to know if I'm affected with this. I would ask, what tools do they use? For example, these are the tools. You remember I said we built a database of the tools that are installed across the infrastructure. I want to know if any of these tools that Scattered Spider is using also in our infrastructure. So I could even ask, let's say, for example, one of these are I want to know if TeamViewer is installed on any of the assets that we have. So what it does now, we have different routers. It knows that it should go to the database and ask and generate a text to SQL based on my prompt, and search the database if we have TeamViewer installed. Again, if it's not sure, then it's gonna go and leverage all the tools that it has, and then the agents. So, which means this is the query that has been executed against the database, and seems that we are quite good. Yeah, thank you very much. That was my time for a presentation. Happy to connect on LinkedIn, and if there are any questions, happy to answer those. I'll be around here.
Yeah, so thanks for the intro. So yeah, I'm Michael, and today we're going to talk about what we've been working on at the research area, and how we've been using Flower with our at TRISE. So just to take a step back, so tokenization is about digitalizing asset ownership and putting that ownership on a distributed ledger. This greatly improves efficiency during the business process, but also enables composability of pretty complex financial strategies. And so it's been a really successful product on our end. And at the moment, we're executing over $500 million in contracts, especially targeting ground-up construction. But we've got over $2 billion in our pipeline. So we are tokenizing on public blockchains, but also on private networks like Canton. And then we're distributing those assets through broker-dealer that are SEC registered, like Republic. So we're dealing with institutions that have a lot of data or small amount of data, but the biggest problem is that all of that data is siloed. The second biggest issue is also that it is a highly competitive environment where you could easily imagine one of the trainer or maybe one of the institution trying to alter the training process to induce a disadvantage to its competitors. So that's why we built RiseMine. So RiseMine is our internal framework that we're open sourcing as a Flower companion framework. So we're really building it on top of Flower to expand it and integrate features such as model governance. So as you can essentially own the model, but also figure out like when do you want to retrain the model, or things like monetization opportunity. We're also integrating verifiability and auditability as we're integrating this into distributed ledger. So we're tracking metadata on the blockchain, and this gives an overview of the provenance of the updates and to ensure that the process is going according to how it should go. This also implements incentive models, so financial incentive model mostly. So to make sure that we have participants and that they are correctly training the model and that they are providing good contribution to the model. And finally, the blockchain and all those integration ensures that we have a robust deployment that ensures that ensures the integrity of the process. And so RiseMine is really the product of our research share. So we've been working on that for now over a year. And so we're really integrating all of those into this library. It's built on 4 core principles, which are the same as our tokenization business. So, and they really complement well with Flower. So the first is to build on a neutral playground. So it's really important for the institutions to not feel like to not be in a favorable situation. So building on that decentralized and neutral coordination layer really enables that kind of behavior. Second is going to be the verifiability. That's also where auditability and transparency is really important and a key principle to the success of tokenization. So thirdly is going to be accountability. So we want to be able to track the contribution of everyone, and this is going to enable us to either discourage bad behavior or encourage good behavior through the incentive mechanism. And then finally, all of that wraps up into the robustness part, where we want to be able to support Byzantine or faulty nodes, and also all the network issues and that kind of stuff. So blockchains and distributed ledgers have a great proven track record for really good uptime. So what we've done to extend the Flower framework is to add a few more rounds or a few more features. So we're going clockwise. So we start with the verifiable trainer sampling. So through the blockchain, we have a random number generator, and this random number generator enables us to sample the different trainers. And this is done verifiably due to being a smart contract. So it's a distributed guarantee of being a correct process. We then, on the trainer side, it's going to verify the model integrity that you receive. So it hashes the model, validates that it's the model that was sent on chain from the previous round, and then it's also going to validate all of the authorization to make sure that it is actually talking with the aggregator. Then there's going to be the classic train process. We then go to the model signature and commitment. So the trainer will sign the new train model, and we'll commit the hash on chain and then send it back to the aggregator. We then aggregate multiple candidates, And this is going to enable us to measure the contribution. So we're going to have, during the evaluation phase, we're going to be distributing those different candidate aggregation, and depending on who is aggregated within that aggregation, we're going to be able to figure out who helped improve the accuracy. So there's the orchestration that is also done on chain. And then the trainer essentially asks the aggregator to get the candidate that he has to evaluate. The trainer then commits the evaluation on chain, which is then fed into the contribution calculation and finally in the compensation mechanism so that it receives the ownership in the model or whatever kind of incentive model that you want to build on. So we've built a blueprint demo. So if you guys want to use it, it's based on real MLP. So this is one of the leading tabular model at the moment. I don't know if you guys have seen, but Tabular Arena is also a good resource to check the best model. It's built using real MLP that we're using at T-Rise, where it's also using RiseMine, Flower, and then there's a Dockerized setup. And so in the README, there's all the instruction for the installation. You're going to be able to generate your private key to interact with the blockchain. So with RiseMine, we also have all the mnemonic management. So that's like how to manage your private key and all of that. We also have the walkthrough available that we wrote this week. So it's going to give you a little bit more insights into how to get your current federated learning Flower setup to use RiseMine. And so what's next on our roadmap is multi-server aggregation. So always in the mind of keeping in mind our core principles of going more decentralization and more towards a neutral playground. We think providing a multi-server aggregation is a really good addition. And then so that's been worked on by one of our researchers at the lab. We also have a paper coming on provable federated inference. So when you're dealing with secure aggregation and those type of security feature, the aggregator doesn't know the model. So in that case, we're deploying provable federated inference, in which the inference is done by the client who has the model, and it's using zero knowledge proof. So there is a cryptographic guarantee that the inference results comes from the model, and that's directly usable in smart contracts. So it all links back to the tokenization aspect, where you can use outputs from model to get access to financial services, for example, on the blockchain. And we're also working on things like dashboards to visualize all the blockchain and Flower integrations. Yeah. So thanks. If you want to use RiseMine, we have some documentation, still a work in progress. And you can reach out to me personally or one of our engineer, Michael the second. Yeah. If you have any other question, feel free to ask me or come and talk to me. Thank you.
Okay, thank you for the introduction. So this is a project that we did in collaboration with several hospitals, several universities, and several companies in Sweden. So the project is about radiotherapy. So in radiotherapy, you treat cancer with radiation to kill the tumor cells. But before you can do that, you have to plan the treatment, so you know exactly where to use the radiation. So you need to segment the tumor you want to kill with radiation, you need to segment risk organs that you don't want to damage, and you need to prepare an optimal treatment plan that will kill as much of the tumor as possible while not damaging the risk organs. And traditionally, this is done manually, so it takes several hours for example, a doctor to plan this treatment. But with deep learning, we can do this much faster to save time in the clinical workflow. So you can do automatic segmentation, automatic treatment planning. But of course, we need big data sets to train these deep learning models. So we have done this in Sweden, federated learning between a number of cities that you can see here. So Stockholm is the capital of Sweden. In the south we have Lund. In the north we have Umeå. And a bit south of Stockholm we have Linköping, where I come from. So we worked with these universities and hospitals to export the data from each city, from the clinical workflow. And we also had support from Scale Out and Research, who are experts in federated learning and radiotherapy. So maybe you are not familiar with Swedish geography, but the distance between Lund and Umeå, that's something like the distance between Los Angeles and Portland, to give you a reference. So it's pretty long distance between these two cities. So we work with MR images of brain tumor patients, so it looks something like this. So every city exported similar data, but they may use different MR scanners. They may have different clinical guidelines for radiotherapy, so the data will be a bit different in every city. But here we want to segment the tumor in yellow. We want to segment something called clinical target volume, that's the tumor plus a margin. And we also want to segment different risk organs, like the brainstem. So this is the task of the network, that it takes 4 MR volumes as input, and it will return the segmentation of these different parts that we are interested in. So this segmentation model travels around in Sweden, in our federation. So we started with using 2 cities, so Linköping and Lund. We could see a small improvement of the federated model when we look at something called a DICE score, which measures how good the segmentation is. So we had about 25 subjects or patients in Linköping, 33 in Lund. And the improvement is not so big, but we think that this is maybe due to that the data is a bit different in every city. So I will come back to that. So this was with the FedN framework made by Scale Out Systems. Then we're now doing trainings with 3 cities using the immediate flare framework. So here you can see some of the training curves when we are training with that framework. So now we got even more data from Umeå. We have not yet done a comparison of the final result, but we're now training with data in 3 cities. And in this project that ended last year, we also demonstrated that we could take these federated models and we can put them in a clinical workflow. So we collaborated also with a company Spectronic, who makes the Saint software, and a company Research, who makes the RayStation software. So we could take these federated models and put them in clinical softwares and show that we could get a fully automatic treatment planning system where the models are trained through federated learning. So that you send in CT and MR images, and automatically you will get a treatment plan for this patient. But as I mentioned, we have differences in our data due to different clinical guidelines for radiotherapy. So we compared the size of the different objects to segment. So in the best case, these numbers should be very similar across cities. And for the tumor, they are sort of similar. You can see here in the middle. For CTV, for some reason, it's much bigger in Linköping, and also for the brainstem, the annotations are for some reason much bigger in Linköping compared to the other cities. So this will make the federated training harder, since there are inconsistencies or differences in the data in each city. So we maybe need more advanced methods to handle this in the federation. So in future work, we want to include even more cities. So we have ethical approval to add 3 more cities. We want to do a comparison for the 3 cities case. We're looking into if we can do federated harmonization of the MR images and the annotations. We're looking into methods for handling heterogeneous and inconsistent data, and we want to compare different aggregation methods. So we had some funding from different funding agencies. We also used the GPU cluster in Sweden to do some federated simulations, which we are thankful for.